Okay, so what I was trying to say, my friends, is that for multiplication, you have to ensure that the number of column in the first matrix is equal to the number of row in the second matrix. If that caveat is satisfied, then we can perform that operation. Okay, therefore, this is matrix A, giving us 2, 1, 3. Then I have 1, 1, 2, 2, 4, 1. Okay, this is matrix A. I have matrix B also giving us 2, 1, 3, 2, and 1, 1. This is a 3 by 3 dimensions, right? This is going to be what? 3 by 2 what? Dimension. Is that okay, guys? I'm saying that we can only multiply A and B, A times B, if the number of columns in A is equal to the number of what? Rows in what? B. Once that is satisfied, go on to do the multiplication. Therefore, this is what will happen. A times B will be equal to, I'll take this row, that's row 1 in column A, drop them on column what? B. That's column 1. Therefore, this is going to be what? 2 times what? 2 plus 1 times what? 3 plus 3 times what? 1 to give me my first element. Is that okay? Second one, I take the same row and drop it on column 2. That is by multiplication. So I'm going to have 2 times what? 1 plus 1 times 2 plus 3 times 1. Let me do this. I'm just maximizing it. Let me clean this side. Those who said they can't follow, I hope you are following now.
Yes, please.
Okay, let's progress. Good. Therefore, I'm saying A times B again. This will be what? 2 times 2 will be what? 4. Plus 1 times 3 is what? 7. Plus 3 times 1 is what? 10. That's my first element. This one is what? 2 times 1 plus 1 times 2. That is what? 4. Plus what? 3 times 1. That will be what? 7. I have here. Next one, I pick row 2. Also drop them on column 1, column what? 2. So you're going to have what? 1 times what? 2 plus 1 times 3 plus 2 times what? 1. The next one you have what? 1 times 1 plus 1 times what? 2 plus 2 times what? 1. This will give you 1. 1 times 2 is 2, plus 1 times 3, that's 5, plus 2 times 1, this will be what? 7. The next one, 1 times 1, plus 1 times 2, that's 3, plus 2 times 1, that's what? 5. Then the last row on those 2 columns. So I'm going to have 2 times what? 2, plus 4 times 3, plus 1 times what? 1. Then the next one, I'll have 2 times 1 plus 4 times 2 plus 1 times what? 1. What am I going to have? 2 times 2 is 4 plus 4 times 2, 4 times 3, that is 12. So that will give you what? 14 plus 1 times 1. This should give you 15. This is 2 times 1 plus 4 times 2. That should give you 10. Plus 1 times 1 should give you what? 11. What I've done is I've multiplied two what? Matrix. Is it okay now?
Yes.
So I can.
Yes, please.
Very well.
What's up? It's not 15, it's 17.
Which one is not 15? Is this one? Okay, so yeah, sorry. So this is 16 plus 1, 17. Thank you. So that is what we have done. Multiply two what? Matrix. That's all about matrix what? Multiplication. But like I said, ensure that you have satisfied the condition that the column for the first matrix is equal to the row for the what? The second matrix. Subsequent multiplication, you can have 3 matrices multiplying themselves. As we have indicated, they must satisfy each other as well. Let me. Yes.
The one you just did, it seems the rule is not being satisfied. You said the column of A should be the same as the row of B, right? But looking at this one, it's like the rule rather is, the rule of A is rather equal to the column of B.
What dimension
do you just saw?
Is it not 3 by 3 dimension for A? I'm not sure you are following the discussion. Can you follow? This is a 3 by 3 dimension. Is that okay?
Yes, I can see that. Yeah.
And this one is a 3 by 2 what dimension. We said that make sure the column of the first matrix is the same as the row of the second what matrix.
Sir, please, is a 2 by 3 matrix, the B.
The B, this is row 1, row 2, row 3.
Oh, okay.
And this is column 1. People, you are confused. Let's make progress. Can we make progress now?
Yes, sir.
Yes, please.
Okay. So let's go on. So that is the same example. So this example we have here in your slide, you see how I've taken my time to row 1 times this should give you that. Okay. The next operation you can perform is a transpose of what? A matrix. If we say transpose, you are just changing or trying to say that matrix that are elements that are in a row can now be arranged in column. Okay, that is the meaning of transpose. Means that if I have given that matrix A is a 4 by 3 dimension and I want to transpose A, I'm writing this as AT, A raised the power T, that's A transpose. A transpose means that I'm moving all the rows into what? Column. It's just by way of changing. Okay, so you see this is row 1, row 2, row 3, row 4. I'm transposing it means that row 1 will become column what? 1. So I'll have 2, 4, what? 3. Row 2 becomes what? 5, 4, what? 6. This becomes 6, 1, 8. And this becomes 4, 5, what? 7. What I have just done is to transpose the matrix. That is what you have here, 2, 5, 6, 4, 4, 4, 1, 5, 3, 6, 8, 7. So transposing a matrix is just a simple operations to what? Perform. Okay. I hope that is also clear with all that I have indicated. We make progress. Therefore, after we're done with the operation, you need to also understand what we call an identity what? Matrix. Because we'll be using identity matrix in the ensuing classes, okay? An identity matrix is just saying that any matrix that is in a square form means that the dimension is n by n. The row is the same as what? The column. Where all elements are on the diagonals are what? Ones. And all other elements are what? Zeros. Therefore, we write any matrix which we call identity by the letter what? capital I, means that this is an identity matrix and they are square matrix. To illustrate that, I'm saying that if I have a matrix called C, C is only called identity, which is I, if it is what? A square what? Matrix. Means that all the elements in the diagonal, on the diagonal plane is what? They are all 1. All other numbers or elements are what? 0. So I can have 1, 0, 0, 0, 1, 0. This is a square what? Matrix.
It's the whiteboard that is showing at the moment.
Oh, okay, it's not showing. Share. Is it showing now? Is the whiteboard showing now?
Yes.
Yes,
okay.
Please.
Okay, so I'm saying that you have an identity matrix, means that all the elements on the diagonal are 1. All the other remaining elements are what? 0. If I have this, if I have some of your internet are not stable, so Ghana. So I, which is an identity matrix, I'm saying that all the elements in the diagonal plane should be 1. Any other should be 0. So I can have 1, 0, 0, 0, 1, 0, 0, 0, what? 1. This kind of matrix is called an identity what? Matrix. So please note that we'll be using that one along the way. Therefore, I should have something like this as an identity of matrix. Please note this property 1 and 2. If you multiply any matrix by an identity matrix, the answer will be the matrix itself. So any matrix that is multiplied by an identity matrix, the value is what? The same. It's going to be what matrix. So matrix A times an even identity matrix of I will be equal to what? A. And an identity matrix multiplied by matrix A should also be equal to what? A. Note this one. I'll be using it along the way in the next class. Then you can have another matrix called inverse of what? Matrix. Inverse of matrix is written as B raised to the power minus 1. So A inverse. So say this is B inverse, A inverse, C inverse. In that sense, we are saying that let B denotes n by n matrix such that if I multiply A matrix A times B, which gives me matrix B times A, and my answer is giving me an identity matrix, we can say that A is the inverse of what? B. I can only get an identity matrix, okay, if one of the matrix I'm multiplying is the inverse of the other. We'll be using this operation very soon. So look here, look at the last one here. I'm saying that, in other words, A inverse is the inverse of A if and only if I'm getting an identity matrix as my answer, then it means that A, which is a given matrix, times A inverse is the same as A inverse times what? A, to give me an identity what? Matrix. In other words, I'm saying that anytime you multiply the inverse of a matrix by a given matrix, you get an identity what? Matrix. That operation is simple. You multiply any given matrix to an inverse of that matrix to give you an identity what? Matrix. Good. I have a question here to say that not every matrix has an inverse. If no inverse exists, then the matrix is called singular or non-invertible. Then my question is that non-square matrices are not invertible. Why? To say that they are not inverse. Remember that if I'm